Hello, everyone. This is Mr. Espinosa, and this semester in IPC, we'll be talking all about physics. If I really wanted to summarize physics into a couple of words, as you can see here on the screen, you can think of it as motion, movement, right? Matter, right? The stuff around us, and energy. And of course, when we talk about chemistry, the previous semester, um, we noticed that these are some of the basic themes that just come up over and over again. Again, you might be thinking, are we talking about motion again? Are we talking about matter again? When we talk about atoms and their electrons and their motion, talk about energy and energy transfer. A lot of what physics is, in fact, the reason why chemistry and physics are called the physical sciences is because they're very much related. But this will be a quick intro into what we're going to get into for this semester, and then for our first unit as we get ready for this semester in IPC. All right, so first I want to mention that as Carl Sagan said, and Carl Sagan was a famous astrophysicist. He was an educator, speaker. In fact, he motivated a lot of people to go into this career. But he said that something that I think is still true, that we live in a society exquisitely dependent on science and technology, in which hardly anyone knows anything about science and technology. And what does he mean by that? If you think about it, the latest iPhone or the PS5 or anything from space travel, or where are we going with space exploration and robotics and all of that, to entertainment, fireworks, roller coasters. I mentioned video games. All of that wouldn't be possible without physics. Um, when you go out to eat, when you go out to travel, you have to get on a car, you have to get on a train, or you have to go on a plane. None of that would be possible without physics, without knowing how things work. And the cool thing about nature is that we can know how it works and we can figure it out step by step. And so we're going to start talk about physics. These are the topics that we're going to get into this semester. And let me quickly go over them. So we're going to start with Unit 6. Of course, Unit 1 through 5 was chemistry. Unit 6 is this semester. We're starting with physics, position, speed, and acceleration. Then we're going to get into forces and momentum, then potential and kinetic energy, and then thermal energy, waves, electricity, and then finally energy and resources. So a lot of these words maybe you're familiar with. Potential energy we talked about, kinetic energy, thermal energy, right? We talked a lot about that when we talked about chemistry. So you'll notice a lot of the same themes. One key difference I think you can kind of think about as we talk about physics this semester is that we're not going to so much focus on the atoms themselves. We're not going to really talk about the electrons or protons specifically. We will, talk about their motion when we get to the electricity, but as far as their nature and things, we're going to kind of think of things more in a macroscopic sense, and in a way that we can, more see and apply. So, and I think that really speaks to what more of what physics is. And so as we get into motion, which is going to be our first topic, a few things that you should know before we get into this unit is, for example, number one, matter is always in motion. Everything around you is currently moving through space, including you. And in fact, by the time you finish watching this video, you would have traveled tens of thousands of miles through space. And you don't really have to go that far. You can think about the last time you were on a train, or last time you were in a car or an airplane. If you look around you, everything seems to be still, right? Everything seems to be motionless. But someone observing you traveling by would see you traveling at the speed that you're traveling with. For example, let's say you're going down the highway at 60 miles an hour. You zoom by, and someone just happens to be walking on the side of the highway, and they see you in your car and everything in your car moving past. Everything to them seems to be going at 60 miles an hour, right? To you, everything seems to be going zero. And so another thing that we need to keep in mind is there are different frames of reference, right? When we compare objects that are in motion, we have to keep in mind frames of reference. So, for example, you guys, presumably you're watching this at a classroom or at home. Everything around you seems to be still, right? And so that would be your frame of reference, right? So your frame of reference is the classroom. The objects around you is the classroom, or wherever you are in your home. That's your frame of reference. If you're on a train, if you're on an airplane, then there's a different frame of reference, because now you're on something that is moving, right? So that's what we mean by that, by frames of reference. And that's how we can make comparisons is by saying, okay, well, we're here in this classroom, let's see how things move. Or me sitting here outside, I can see the leaves rustling by, or I can uh, hear the wind or feel the wind even moving or moving some of the branches. And so, so this is, a little bit of a different frame of reference because of all the different things that are happening around. But I can still, compare things. I can still compare motions. For example, this tennis ball and this ping pong ball. I can still see them. If I threw one or if I threw the other, I could still compare them because we're in the same frame of reference. Okay. And so, how do I cause a change in motion, right? So I mentioned throwing one of these. So if I use some amount of force, and that's another thing that we can talk about is a push or a pull, right? And that's what's required if you want to change the motion of something, right? If I want to change the motion of this tennis ball, if I want to change the motion of this ping pong ball, I'm going to have to use a force. I'm going to have to push them away from me, right? And so that's one of the things that we'll talk about is something called forces, energy. So once you use a force on something, cause something to change in motion, you're causing a change to that object's energy as well, right? If for example, you can observe both of these balls. If I just leave them alone, they're on a bench, and since we're kind of using our frame of reference as just like out here, this bench, we're not really thinking about what's going on outside the space or anything. We're just kind of focused on what's happening here. Then I could say that both of these balls on this table here are both at rest, and so they have a certain amount of energy. But they're actually on a table, and so if I were to tip one over and cause one to fall down, then that's going to cause a change of energy. And so that's another thing that we'll talk about, which is that. But these are the first four things that you kind of have to keep in mind as we go into this unit. One, matter is always in motion. Everything around you is always in motion. Frame of reference, you have to keep in mind. Okay, where are the objects, and can we compare them? Change in motion, what causes that change in motion? We talk about forces and acceleration, and then what does that cause in terms of the energy? And we'll get to that as well. And so that's going to be our first unit, which is going to be Unit 6, motion. Here's a few things that we'll talk about as we get into this unit. Something obvious that we'll spend some time talking about is sports, things like roller coasters, what causes an acceleration, what causes a change in motion, are things that we'll focus on because those are some of the more interesting things when it comes to studying this topic. And so I'll see you then.